Welcome to another video lecture in section 5. In this video lecture, we'll study about the concept of sign extension. What is sign extension? Sign extension is the process of converting a number with a given number of bits to a number with a larger number of bits. So for example, supposing we have a binary number given to us which is 11010101. This we can convert it into a 16-bit number. So we start by first writing down the bits from the least significant bit and we pad up the remaining 8 bits with zeros. So our original 8 bits are shown here and the remaining 8 bits on the left become the padded bits which are 0. Now, sign extension is needed when we are to carry out the addition of two binary numbers with different number of bits. So for example, if we have an 8-bit number and a 32-bit number, if we get the correct result, we must convert the 8-bit number to 32-bit number, and this process is called as sign extension. As an example, let us take two numbers. The number given to us 8, this is of course a number in the decimal system, and its equivalent in binary is 1000. Another number given to us is 9 in the decimal system and its binary equivalent is this. When we carry out the addition of these two numbers, the result we get is 10001. This is of course in binary again. So we can see that the two original numbers, binary numbers, were having 4 bits each, but the result is made up of 5 bits. So when we add two binary numbers, the result may extend by 1 bit, and the resultant binary number may need one more bit if there is a carry. So this one is the carry in our addition. To represent such a result in the correct form, we must allocate an additional bit for representing the magnitude of the numbers. What it means is, if my two numbers were of 4 bits each, the addition of these, the final result cannot be accommodated in 4 bits, and so we must do an sign extension, or we must extend the number of bits. As a first example, let us see the sign extension of an unsigned number. So what is the 16-bit representation of the 8-bit unsigned number? Now we are told that this number given to us is an unsigned number. So here is the number 10110010. So all the bits contribute towards the magnitude. We have written the original number given to us here. This is the least significant bit. Now the process of this conversion is very simple. Since this is an unsigned number, we will just copy down all the bits starting from the LSB into each position in the 16-bit number. So we copy these bits, and now the remaining 8 bits will be all filled up with zeros. So we fill up these bits with 0 because our number is an unsigned number. In this example, let us understand how we do the sign extension of a sign magnitude number. So let us start with the example. We are given here a number 100000111. This number is in the sign magnitude representation. So the bit in the most significant position, MSB, this bit represents the sign of the number, and the remaining bits contribute towards the magnitude. So we wish to find what is the sign extension value of this number. So we first copy down this number in the 8-bit position, and this is our least significant bit. Now the method to do this will be, we first move the sign bit of the 8-bit number. This is the MSB of your original number. It is also the sign bit. So we move this sign bit to the sign bit of the 16-bit number. So this is my 16-bit number, and this 16-bit number will have the MSB as the sign bit. So we move the MSB of the 8-bit number to the MSB of the 16-bit number, right? Okay. Thereafter, we will copy the remaining 7 bits of the original number starting from the LSB. So we copy the remaining 7 bits, and now last bit 1 has already been copied into the most significant bit of the 16-bit number. So we do not copy this bit into our new number, rather we put a 0 in the new number, and all the remaining bit positions will now be marked with a 0. So that becomes the sign magnitude representation of 16 bits, right? Okay. In this example, let us consider the sign extension of 2's complement number. Now, to convert a 8-bit 2's complement number to a 16-bit number requires again 2 steps. Let us consider the original number given to us, that is 1110, 1110. This is already given to us in the 2's complement representation. We write down our original number here. This is the most significant bit, and we have here the least significant bit. Now, to convert this into a 16-bit equivalent number, the procedure is as follows. We will first copy down the 7 bits starting from the least significant bit. So here are our 7 bits. We copy down these 7 bits into the respective positions in the 16-bit number, and now observe this most significant bit in the 8-bit representation, this is our most significant bit. This high bit, we will copy it to each of the remaining positions in our new number. So this bit, the high bit, will be copied into each of the positions which are now vacant in the 16-bit number. So we'll have all these positions being filled up with 1.